And hello everyone, welcome back to our discussion on snappyHexMesh. So today we want to talk about the simple stereolithography format, or else known as the STL file. And in the last video we talked about some of the basic concepts of how snappyHexMesh uses the STL file, the stereolithography file, puts it into an existing block and carves that mesh out for us. And so first thing first, if you have not learned how to generate a STL file, well, this video is going to show us some basic demonstration. Normally STL files are generated using CAD tools or computer aided design. So it can be AutoCAD, it can be FreeCAD, or lots of CAD software. So I'm just gonna do CAD software. So you see AutoCAD, 3D CAD, whatever CAD. So you can see some of the lists down here. You may or may not be familiar, like 3D Builder, 3D Slash. You can see all these design, all these ways of designing. So you're able to draw blocks and diagrams and complex shapes without going through a very command line interface. Now some of these CAD software is quite expensive, but we'll start using the very simple one known as 3D Builder, and this should be available inside your Microsoft App Store and is able to be downloaded for free. If you're not able to use 3D Builder, of course we can go and use some other file to generate our CAD, our STL file, our stereolithography file, and that's not an issue as well. I just go for the simplest one, the most free one. That's what we are going for. So I'm gonna start a 3D Builder, and unfortunately all of these are in Chinese, so I'll try and translate as we go along. I can't remember how we actually configure the language functions, but this one, it just means create a new file. This one means open up an existing file. So I'm going to create a new file here. So let's say we want a cylinder, right? Okay, you just click a default cylinder, and what this means, this character here, it just means millimeters. So it's centered on x equals 0, y equals 0, z equals to 20. Now if you want to check the size, we look at this green arrow. Okay, wrong arrow. That one shifts it in the x and y direction. Of course you can click and press 0 and it'll do just that. Scaling, just look at this is for shifting it left and right, up and down. This is for scaling. So you can see this box here, you just pull it aside, back and forth like that. Of course you can type in the number manually, and you can recenter it using numerical numbers, and that's not an issue as well. Again, all of these are in millimeters. Okay, so let's say we want to make 1 by 1, a very thin cylinder, a stick like thing almost. We can do it like so. Okay, so that's a very thin cylinder, almost like a pipe, very long pipe. And then let's say we just want to save it. So to save it, just look for the floppy disk button, which is Ctrl S. So we'll save it as a cylinder in STL format. Okay, so that's the OK. Alright, we'll have a cylinder in STL format. And what do we do next with this cylinder? Well, we can open it up in ParaView. So I'll just delete this old one. Cylinder.stl and press apply. And to add access to it, we can just use the access grid here, and that will give us the x, y, and z axis. So you can see all these numbers are in millimeters, right? That's the intent of that 3D builder. And most CAD software will be designing in millimeters, not in meters or other kind of units. Maybe some do cm, but you'll have to take note, all right? Because there is some problem when it comes to importing it into OpenFOAM, right? So let me draw some kind of a diagram to show you what I mean with this unit conversion. So let's say you have CAD software, and let's say you wanted to design a 40 mm thing. All right. So when you export this STL file, right? You export this STL file. This STL file is just going to remember the number 40. There's no unit attached to it. And when you put this STL file into OpenFOAM, you're going to have a problem. What kind of problem are we talking about? OpenFOAM is going to look at this number 40, and then it's going to say, oh, this is 40 meters, not 40 millimeters. So what the STL file actually contains is just a number. For example, this number 40. When the CAD software sees this number 40, it's going to interpret it as millimeters. But when OpenFOAM sees this number 40, it's going to interpret it as 40 meters. So this is something we'll kind of have to take note of when we import our STL files into OpenFOAM. Okay. So I am going to exit this, and of course, if you want to see a more complete-ish example of what we are going to end up with, we can look at this thing called Pipeflow snappyHexMesh. Okay, so that is on my GitHub page, where I have made a very crude version of this a cylinder cutout using a snappyHexMesh. So this is known as Pipeflow snappyHexMesh. I'll put the link in the description, so you can use Git to download these files, and you take a look and modify your own snappyHexMesh file. Okay, this is just to kind of give us an idea of the process. Okay, so now we have this STL file. Where are we supposed to import it into? Now, the idea is to have it in the constant, and then you will have this file called triSurface. So triSurface is basically where you store all your 3D and STL file, and this is to be spelled in such a way, triSurface with a capital S, because things are case sensitive here, so that when you run your snappyHexMesh, snappyHexMesh knows where to find your surfaces. So next thing we want to do is to copy this over into some kind of a triSurface dictionary. Okay, so I'm going to just ignore this completed file, and I'm going to start from scratch. Let's go to OpenFOAM files. Yep, and let's see the cavity folder. Cavity folder is clean, and we are very familiar with the cavity folder. So I want to copy this cavity folder, and then you'll rename the folder Snappy Pipe. So we'll call it Snappy Pipe folder. Okay, Snappy Pipe. So let's go to Snappy Pipe. Right, all the same. So we'll need to make a directory known as the triSurface. So let's put it in the constant. All right, and then we'll need to make a directory known as triSurface. So that is what happens. So you can continue to triSurface. Okay, so this is the directory we want to have our 3D STL files in. So we want to copy it from the desktop now, so we go to C mount and C. That will bring us to the Windows side of things. We go to users, alright, and we go to my username, and we go to desktop. So where is it? Where is the desktop thingy? Desktop thingy is here. We are in the desktop. You'll see lots of things here. We want to look for this thing called cylinder.stl. Can you see this cylinder.stl? Yeah, so what we need to do is simply this cpar cylinder.stl, since it's in this folder, and then we'll want to copy this folder to make sure it's placed in OpenFOAM. Let's try Surface. So cylinder.stl, cpar cylinder.stl, and then we want to put it into the triSurface folder and put dot down there. So let's see the triSurface, and then we have a simple cylinder.stl. So we have successfully imported a cylinder.stl file into our OpenFOAM directory, and then we are having it in the triSurface directory. So that's basically how we import STL files. Create a very simple STL file, and we've imported it into our Linux directory. And next thing we want to do is, of course, figure out what the proper scale is. Then we can start our snappyHexMesh thing. So thanks for watching with me. Thanks for bearing with me for the last 10 minutes or so. Next video we'll want to continue to see how we can create the block mesh, the background mesh required to fit this cylinder in. So thanks for watching. I'll see you guys next time.